Okay, at this point I assume you've worked the problem. So let's go over it. Find the average acceleration. Remember, average acceleration does not actually use acceleration. It uses velocity. So you want v of 8 minus v of 2 all over 8 minus 2. So using your table, negative 120 minus 100. 8 minus 2, you end up getting negative 110 over 3 meters per minute squared. And that was worth just 1 point. They didn't specifically say give units, so they didn't grade you on that, but it never hurts to give them. Okay, so part B says, is there a time when the velocity is negative 100? Well, just logically, looking at these values, yeah, because velocity is continuous, so you know it's got to be sometime in between here. But we need to show that. So the fact that's asking when does the function, velocity, equal negative 100, then we got to use the IVT. So we need to say, okay, well, velocity is continuous on 0 to 12. So the function is continuous on the closed interval. V of 5 is 40 from the table. V of 8 is negative 120. Okay. So the IVT states that V of t must equal negative 100 for some t in the interval. And they specifically asked for the interval 5 to 8. They flat out told you that. Okay, I believe in the problem. Yeah, they did. So you could use 0 to 12 or 5 to 8. It doesn't really matter. Okay. And because, well, we need to actually state that negative 100 is in fact between negative 120 and 40. So the y value they gave me is in between my two y values. So therefore the IVT states it must equal that. 2 points for that. 2 points. 1 point for having this kind of statement somewhere of some kind, and then 1 for stating the IVT. Part C. So at t equals 2, you're already at 300. And they want an integral for the position of train A. So you already started 100. Okay, then you have to add, well, if you've got the velocity in your problem, the antiderivative, which is an integral, is your position. So we want the position from 2 to 12, because that's when we're starting at t equals time 2 of v of t dt. And boom, you got a point for that. That's my position. Okay, now I need to use a trapezoidal sum with 3 subintervals to estimate that. So I right away have the 300 plus, then I have 3 halves, 140, 3 halves, negative 80, 2, negative 270. And once again, we're just using the trapezoidal rule. 1 half, they're 2 apart. Oh, I'm sorry, we're on 2 to 12. Sorry. 1 half, they're 3 apart. Then base 1, base 2. 1 half, they're 3 apart, base 1, base 2. 1 half, they're 4 apart, base 1, base 2. Can't use a formula because they're not evenly spread apart. You end up getting negative 150. And that is meters. They didn't ask for it. So there we go. That part C was worth 3 points. 3 points. Okay, part D, you have a second train that's going north. So you have one going north and east. This is just a basic related rates. You can draw a picture if you want. We know A is going east, B is going north. Okay, so we know our equation is A squared plus B squared plus C squared, or equals C squared. Couple of things we know. We know from part C that A starts at 300. And this part, so A is 300. And this part they tell me B starts at 400. Using the Pythagorean theorem, that means at that same moment C is 500. Okay. We know the velocity at A, which I'm going to use dA dt for my notation. Using my chart, well, the velocity at time t equals 2 is 100. Then my velocity of B at time t equals 2, well, they give me the equation of the velocity, so I just have to plug in 2. I end up getting 125. Related, right? So 2a dA dt plus 2b dB dt equals 2c dc dt. Plug in everything we know. Solve for dc dt. We end up getting 160 meters per minute. That was worth 3 points right there.